Hi, and welcome to Visualization with Seaborn. Today, over the course of the next 25 minutes or so, I'm going to guide you through how we can use Seaborn, a Python library for visualization, to generate high-quality statistical plots, statistical visualizations, that help us explore and understand our data better. Before we get started, I would like to mention that even though the next 25 minutes will be relatively theoretical, they'll be just slides, I also have produced a Jupyter notebook that you can find on the GitHub in the link that you see on your screen right now. So let's get started. So first of all, let me introduce myself. My name is Bruno Gonçalves, and I'm a senior data scientist that for the past 10 or so years I focused on using large-scale datasets obtained from social media and other sources to study human behavior. So essentially, understanding how we can use large-scale datasets that are relatively freely available online to understand how people interact with one another. Of course, one of the things that I dedicated some time over this period was precisely in understanding visualization and how we can use visualization for our purposes and to generate high-quality figures and plots that actually transmit the message we're trying to transmit, and not only that, help us understand our datasets much better in a much more meaningful and deep way. So here we have some quotes from some of my favorite authors in visualization that highlight kind of my philosophy towards visualization and kind of explain why we should spend some time understanding these libraries and actually putting them to good use. The first one, by David McCandless, says that information visualization is a form of knowledge compression. What that means is that we're able to take advantage of all of our cognitive abilities or all of our visual acuity and capacity to understand and process information if it is laid out and displayed in a proper way. The second one, by Edward Tufte, also a legend in visualization, is that there is no such thing as information overload. There is only bad design. And this again highlights the point that if you're able to design things properly, you're able to convey a great deal of information and to also process a great deal of information just visually by taking advantage of your visual cortex. The third quote by Hans Rosling says, "Never leave a number all by itself. Never believe that one number on its own can be meaningful. If you're offered one number, always ask for at least one more, something to compare it with." And here I would add that the best way to compare numbers is precisely to plot them on a specific scale where you can highlight their relationships, their similarities, and their differences. And finally, the last quote by James Stuckey, one of the founders of modern statistics, is that the great value of a picture is when it forces us to notice what we never expected to see. And this is one way of saying that we should use visualization to better understand our data and to notice and highlight unusual or unexpected patterns in our data, which can be meaningful and can give us information and deepen our understanding of the process or the system that we're studying, the process or the system that generated our data. Why Seaborn? So this is of course a question we should be asking, and the answer is very simple. Seaborn is a Python package, high quality Python package that's open source. It was designed from the ground up to be a statistics visualization package or a statistical visualization package. And what that means is that it is optimized to allow us to easily manipulate and slice our data in different ways to generate statistically meaningful plots that we can not only use as we are exploring our data, but also have enough quality that we can build up towards a final product, a final plot that will go into a publication or website and so on. And one of the great advantages of Seaborn is that it builds up on pandas, one of the standard libraries for data extraction and manipulation. And it's able to generate matplotlib objects by default in the background, which makes it very easy for us to customize its final product and to put it in the format that we want and that fits our expectations and our requirements. Another great plus of using Seaborn is that it has a great online documentation and also a great online library and gallery that not only displays its capabilities and a wide range of plots that it's able to generate, but it also gives us the source code that was used to generate these plots. So you can always use it as a starting point that we can then customize and adapt to our needs and to our specific data sets. So if you go on the gallery and you see a specific kind of plot that you find interesting, that you think might be useful for you, you can start building up on it almost immediately. The first step with any Python package is we import Seaborn traditionally by doing import Seaborn as SNS. Seaborn takes pride in having a flat namespace, and what that means is that all of its functionality is available on the main module. So all the functions we're going to mention are essentially invoked by simply calling sns.functionName. Another advantage of Seaborn is that it makes a few standard datasets easily available. You can just call sns.load_dataset with the dataset name, and you will happily load it for us and return it as a pandas data frame. Again, highlighting its integration and reliance on pandas. In the examples of the notebook that I uploaded to the GitHub, we'll be using the tips dataset, which is simply a small dataset of restaurant bills, tips, party sizes, the gender of the server, which will of course have some continuous variables, some categorical variables. It's relatively small, so it's easy to play around with. In Seaborn and in visualization in general, there's essentially two different types of plots that we have to consider. We have relationship plots that essentially relate one continuous variable to another or more, so two or more continuous variables. We have categorical plots where at least one of the variables is categorical. And what that means is that we can slice the data according to the values of this categorical non-continuous discrete variable and look at how the other features behave within each. So Seaborn is able to support a large number of different kinds of plots, both categorical and relational. The relationship plots, the relational plots that it supports off the box are scatter plots and line plots. So these are just the most common ones, where it's just drawing points and lines for x and y. This is perhaps the most common type of plot we're familiar with. For the categorical plots, we have 8 main types of plots. So we have strip plots, swarm plots, box plots, and so on. And all of these functions that I mentioned so far and that I'm highlighting here in this slide are what is known as access functions. And what this means is that they essentially generate a matplotlib access object, so one specific plot. Of course, one figure can have one subplot or more, and if you want more than one subplot within your figure, then you have to use what are known as figure level function. And for figure level function, essentially you have two functions. One for relationship plots, sns.rel plot, and one for categorical plots, sns.catplot. And here you select what type of plot you want, so scatter plot or line plot, strip plot, swarm plot, or whatever, by specifying the kind parameter. So you'd call sns.rel plot with kind equals scatter to generate a scatter plot, with kind equals line to generate a line plot, and so on. Other than the distinction between generating an access object or a figure object in matplotlib lingo, they're roughly equivalent. And what we mean by roughly is that they will generate the same kind of plot with approximately the same aspect, visual aspect. So here is an example. Here we're using a sns.rel plot to create a relationship plot between two continuous variables. We're specifying the kind of the plot to be scatter, so this will be a scatter plot. On the other hand, contrast that with the equivalent access level sns.scatterplot. You will see that it's showing the same data, but now the figure is a little bit wider and rectangular, while for the figure level plot, it tends to be, by default, square. So you can see that they're roughly equivalent with some differences in style. So in the remainder of this quick lecture, we're going to be focusing on the figure level plots. Always keeping in the back of our mind that essentially what we do with figure level is also doable using access level plots. And in particular, we'll see later on how we can use any kind of plotting function we want to generate our plots and take advantage of the slicing capabilities of figure level plots as well. Before we do that, we have to understand exactly what is the basic function structure. As I mentioned, Seaborn is built to take explicit advantage of pandas. So every plotting function can take a pandas data frame as an input. It will extract the data it needs from this data frame. One other advantage of this is that we can specify what we want to plot on the x-axis, the y-axis, and so on by simply providing column names from this data frame. That makes it very easy to try different things, plot one column versus another, or then switch to another, and so on, simply by changing the column names. And Seaborn takes care of the data slicing for us. You can also assign column names to other properties, like hue for color, size for symbol size, style for the type of symbol you're using, etc. And when you do that, essentially what Seaborn is going to do is it's going to slice the data according to those properties and use the values in those columns to represent your data. Since these are figure level plots, by changing the kind parameter, we can change the type of plot that we're displaying. So you can see already how, even though these functions tend to take a large number of arguments, it makes it very easy to try and experiment with different kinds of plots and different kinds of visualizations. To make it clear, here's a quick summary of the arguments that typically you would use in a figure level plot. So for a relationship plot, you would typically have an x variable, a y variable, a hue, possibly style, data you always have. This is the parameter, the argument where you specify the data frame that you're going to be using. And of course scan, which again you also always have, which specifies the type of plot you're generating. X, Y, hue, size, and style, of course, are just column names in the data frame. In the case of categorical plots, you can also have orient, which tells you whether you are aligning things vertically or horizontally, and order, that specifies the order in which the categorical values are displayed. This is done when one of the variables is categorical, like it's typical categorical plots, but can also be useful to order the colors that it uses when you're using the hue parameter, the size of the markers in the plot, etc. And for those you would use hue underscore order, style underscore order, size underscore order, and so on. And as we mentioned, one of the main advantages of figure level plots is that they're able to generate subplots very easily. So you can use this as a way of seeing the different facets of your data, the different angles of understanding your data. And the way you do this is by specifying the row or column, what column it should be using to slice your data and display it in the subplots in columns and in rows. You can generate easily a matrix or a grid of different subplots where you have some features of your data aligned along the rows and other features of data, if you want, aligned along the columns. Figure level functions, as we mentioned, will return an array of access objects. So what this means is they will generate essentially a grid of subplots and they will give you access to the access object they generated for that specific subplot, so then you can use all your knowledge of matplotlib to customize it and adapt it to your needs. Let's look at a quick example. So here is a piece of code that is also in the GitHub repository. For ease of reference, I've included the link again on the top right hand corner of this slide. So you can see that we have many different parameters in this function. It's a sns.relplot, so we're plotting relationship plot. You can see from the kind that it is a scatter plot. When plotting on the x-axis the total bill, so this is basically what was the final amount that customers paid. On the y-axis we'll see the tip, so we expect that as the bill increases, the tip increases. For hue, we have the sex of the server, so this, which basically will mean that males will have one color, females will have another color. The size of the markers, because this is a scatter plot, will be given by the column size. So basically the size of the party, how many people were at the table, will be used to specify the size of the symbols used. On the columns, we're going to represent if it was a smoking table or a non-smoking table. And on the rows, we're going to specify the day of the week. So you can already see that we have many different features that we are displaying all at the same time. We have the total bill, the tip, the sex, the size, whether or not it's a smoking table, and the day of the week. And in the style type, so the marker that's being used to represent each dot, each point in our scatter plot, we also have the time. And this basically says if it's lunchtime or dinner time. So you can see that essentially we have 7 different features that we're all encoding in a meaningful way, and in a way that makes it easy to distinguish the different characteristics and what we're referring to in each subplot in one single line of code. Then not only that, it's also easy to understand exactly what it's doing. Further, we're using row order to specify the order in which we want the rows of our figure. So we have Thursday, Friday, Saturday, and Sunday from top to bottom. Here, we're displaying only a subsection of it, so just 2 by 2 instead of 4 by 2. So to make it more clear, you can also see how on the top of each subplot, Seaborn automatically adds a little annotation describing what is the slice of the data that is displaying here. And on the right hand side of the figure, you can also see how it generates the legend. So it shows you not only the type of marker it's using, the sizes and the colors. Essentially, every time you call a figure level function, what Seaborn is doing in the background is generating this matrix of subplots, and it's assigning each specific slice of your data to one of these subplots. In the background, what it's actually doing is it's generating a facet grid. So a grid, so representing a matrix of different facets of your data. You can also do this yourself. You can generate a facet grid object manually by assigning it the data you want it to use and how you want the rows and the columns of this facet grid to be, so how you want the slices to be organized along the rows and columns, and this will generate a facet grid object. After you have this facet grid object, you use the map method of this object to essentially plot your data according to whatever specification you want. So essentially, the facet grid object will define the grid and how it's going to slice the data for each of the subplots, and then you can arbitrarily use whatever function you like to generate each of the subplots. You can use any matplotlib plot function if you want, just easily, just putting the function name as the first argument of the map function, or you can write your own function. You can use any kind of arbitrary code to generate its figure, as long as it operates directly on the current matplotlib access object. In the Python notebook, we have an example on how to do this exactly. But essentially, as long as you have any function that generates a plot, you can pass it to the map function, and that will generate your plot. Your function, the only requirement is that it must know how to plot the data when provided as a series, and it has to take several keyword arguments that, of course, Seaborn is going to use to tell your function what the color should be, what the size should be, and so on, depending on the type of plot exact that you're specifying and the parameters you're specifying. Facet grid will also return as one of the fields of the object after you plot it the array containing all the access objects from matplotlib that then you can use to customize your figure any way you like. Seaborn also provides two specialized versions of facet grid. One is pair plot and one is joint plot, that are useful to generate very specific kinds of facet grids. So pair plot will generate a matrix of plots where each row and each column will essentially be one of the numerical continuous variables in your dataset, and you'll just plot them, all the pairwise comparisons between them in the off-diagonal elements, and in the diagonal elements we'll plot the distribution of those same variables. Joint plot will generate some main plot in the center, and on the margins of this plot will generate the distribution of points along the x and y dimensions, as we have in this example here. And these marginal plots are useful when you're trying to understand essentially what is the distribution of points in your data, right? Both in the x and y dimensions. This brings us and gives us a nice excuse to discuss as well the third kind of plot that Seaborn supports. You recall that in the beginning I mentioned there were essentially relationship plots and categorical plots, but there is also a third type. The third type is distribution plots, and these are essentially ways of visualizing distributions in your data, both univariate and bivariate distributions, so one variable and two variables together. Again, you can slice your data by rows and columns, and this plot will return the facet grid object with all the access objects as before, that you can then use to build up on top of. So just to summarize, so this plot will accept the same kind of arguments as rel plot and cat plot, hue, data, row, column, and so on. And for the kind parameter, it accepts 3 types, essentially hist for histograms, KDE for kernel density estimate visualization of the data, and the CDF for cumulative distribution function, so to show you the cumulative distribution instead of the actual distribution. So, of course, this is the figure level functionality for this plot. There's also the axis level, where you just have sns.histplot, sns.kdeplot, and sns.ecdfplot. Now you have a good understanding of the 3 main categories of plot that Seaborn is able to support: relationship plots, categorical plots, and distribution plots. You can see and explore examples yourself on the Jupyter Notebook in the GitHub repository that you have on your screen right now. I encourage you to explore it and play with it yourself to get more familiar and to get more comfortable using it. And if you have any questions, feel free to reach out to me during the Q&A or even later through social media. So here is my contact information. You can also subscribe to the newsletter I run every Sunday morning, the latest in blog posts, tutorials, videos, and so on data science, machine learning, and artificial intelligence. So thank you so much. It was a pleasure, and I'm looking forward to hearing more from you. Bye.